Hello, my name is Shannon Smith. I'm a doctoral candidate in educational studies at the University of Cincinnati, and I'm also a high school chemistry teacher here in the area. Today, I'd like to share with you the design and preliminary work for my dissertation, which centers on misconceptions that students may have in chemistry, how to uncover those and work toward better understandings. I welcome your feedback and ideas if you would like to share. Chemistry is a difficult subject for many students. What's particularly difficult from a teacher's perspective is that students can develop ideas that aren't consistent with the way chemists think. They develop misconceptions about phenomena, they hold on to them, so these misconceptions are hard to change. And they'll even go so far as to hold on to their misconceptions when they're presented with new information and a correct explanation of observable phenomena. So understanding these misconceptions is important for learning. Many chemistry educators believe that to understand chemistry, students need an understanding of the topic from three perspectives, including the macroscopic, what they can see, the symbolic, which includes models and graphs and things that represent phenomena, and the particulate or the submicroscopic, what students can't see but generally must imagine. Most agree that it's the particulate level that is most difficult for students to master and also the most difficult for teachers to assess. It leaves a door open for misconceptions, so focusing on this third angle is important for teachers and for students. And developing tools for teaching at the particulate level could be advantageous. The Johnstone Triangle is a pedagogical framework for explaining these three perspectives of understanding chemistry. And since the particulate or the submicroscopic is so important, I'm most interested in that one and have focused on that for my dissertation work. The purpose of my project is to better understand what misconceptions my students might have by examining their representation of this third angle, the particulate angle. Throughout the semester, I'll be targeting my instruction so that it includes numerous opportunities for students to analyze and generate these particulate level drawings, or PLDs. And I hope that this carefully planned instruction will have an impact on misconceptions and overall learning, especially on the particulate level. The three research questions I'm trying to answer include what misconceptions are revealed when students answer questions about the particulate nature of matter, what misconceptions might be revealed when students represent phenomena with drawings and then explain those drawings, and lastly, how are students' misconceptions affected over time by instruction that focuses on particulate level perspectives. This procedural diagram has a lot of information. It shows that this is a concurrent mixed methods study. There are 29 students participating. The quantitative strand is used to investigate research question 1. What misconceptions are elucidated when students answer concept inventory questions about matter on a particulate level. And these are previously published and validated questions from other researchers. The qualitative strand is used to investigate research question 2. What misconceptions are revealed when students draw and explain in their own way and on a particulate level some phenomena that they observe. These are very rich data sources that are generated after students have observed some sort of chemical process in which they illustrate and explain what happened. The integration of the two strands with data over time will hopefully reveal interesting congruent and discrepant results between the two strands and eventually lead to a better understanding of the influence of targeted instruction and the generation of a rubric that teachers can use to analyze PLDs in their own classrooms. Currently, I'm in the data collection phase of this project. One round of data has been collected, and there are 2 more rounds to go. Round 2 will be collected this month, and round 3 will be collected near the end of the semester. Preliminary quantitative data from the concept inventory questions in round 1 show variation in the number of correct responses to individual test items, which we can see which questions were commonly answered correctly in green or incorrectly in blue. Also, item analysis, which isn't pictured here, shows which incorrect answers were prevalent. And interestingly, there are some incorrect answers that are chosen far more frequently than others, and that's probably a result of the careful design of the concept inventory questions that I've used in the study. There are particular questions I'll monitor over the course of this semester, as well as general performance. This is both for improvement in accuracy and for the misconceptions that might be indicated are prevalent in my student population. For example, my students at this point appear to have misconceptions regarding stoichiometry and mole ratios, as indicated by prevalent incorrect answers to questions 8 and 10. For qualitative data, I'm relying on particulate level drawings and explanations from students. This is an example of a particulate level drawing from participant 1. And so you can see that this person has represented a reaction between magnesium and oxygen to form magnesium oxide. Here we have some initial themes that have emerged encoding both drawings and explanations from students. Some examples of themes include things like particle size, particle proximity, conservation of mass or conservation of atoms, what type of bonding is shown, kinetic energy of particles. I expect more themes will emerge as I work. Some of these are expected based upon what's noted in the literature, and others may not be expected. As qualitative analysis continues and themes are revised and eventually collapsed into categories, a rubric will be generated that will look something like this, where we have a tool that teachers can use to evaluate particulate level drawings of their own students to elucidate misconceptions that may be prevalent. The next step in this study is to collect more data. 2 more rounds will occur over the course of this semester. I'll compare quantitative results over time. I'll compare qualitative results over time, again, revising themes and codes during that process. I'll integrate findings and eventually complete the rubric. Thank you very much for your time. I appreciate any feedback that you would like to offer.